So, I in the previous video I explained how we can one important aspect of the data is the variability, the spread, and and as an example, I used the example of Honolulu and Phoenix, and similar idea can be applied to other more practical topics in economics. For example, when you study income inequality, what's important is not the mean. So mean average income is not about the inequality. We have to think about the variability. So how poor the poor are and how rich the rich are. So that's if you apply the same idea to income inequality, you are measuring income inequality. And in finance, you it's not like of course average return is very important, but also important is the risk. And the risk measure is related to how low the worst scenario is and how high the best scenario is. So you want your investment to be stable, which means the lows and the highs are close to each other. That's about financial risk, and it's measured by the variability of returns, financial returns. And in manufacturing, so like say when you make something like when you make a pen like this, say in terms of the length, your if your manufacturer is good, then the length will be similar. All the products must have the same length. So the variability, if some pen is too long, but if others are too short, then something is wrong. Your manufacturing process is not precise. So the variability of manufactured output can be a measure of the precision of your manufacturing technique. So so to incorporate to accommodate these ideas in these examples, we will define two types of measures of variability. Remember, in the previous chapter, we defined like broadly two types of measures. One is the mean, which is the most powerful measure, and the other, an alternative to the mean, is the median. And as an extension of the median, I briefly mentioned percentiles. Percentiles at the end of the slide. So anyhow, there are two types of measures in the previous chapter, and we are going to use similar ideas here. So there are two types of measures of variability we will study here. One is percentile-based measures, which are range and interquartile range. They are based on the idea of median and percentiles. So it's related to percentiles. And the other type of measure of variability is mean based. It's related to the mean. So variance and standard deviation are typical, the most famous mean based measures of variability. So if you understand the structure of the measures, what's defined what's related to what, then it will be easier to understand, to follow. Let me start with the simplest measure. The first measure we study is the range. The range is simply the difference between the maximum and the minimum, right? So the greater range is the greater variation in data. So as I said, Honolulu has very low highs and very high lows, right? Very uh, cool winter and warm winter and cool summer. That's Honolulu. So its range is pretty small. So the maximum in summer 87, 88, in winter 66. So throughout 1 year, the temperature only varies about at most 21.6 degrees. That's Honolulu. But Phoenix, the summer is hot and winter is cold. So the variation is 50 degrees, more than 50 degrees. Then clearly, if you compare these two numbers, you can tell which is Honolulu's and which is Phoenix, right? Phoenix has much bigger temperature uh, variations, and Honolulu has much more stable temperatures throughout the year. So this is the measure. This is how we measure and how we compare two weathers. It's really simple and really intuitive, very intuitive to understand. You know. However, the problem here, or critical problem here, is that they are extremely sensitive to outliers. So you are finding the maximum and you are finding the minimum. And so, like when I say outlier is sensitive to outliers, think about this. Suppose that in Honolulu, so you have, say, a 1 million data. So you observed weather in Honolulu uh, for the past million days. I don't know if it's possible, but say, well, you measured temperature a million times, but suppose that one of them was, say, 70 degrees, but by mistake you read it as 10 degrees. So you misspelled or mistyped 70 as 10. Then suddenly the minimum becomes 10 because of one error in million. So it is outlier caused made by the error, and the one small outlier, one small error, or like actually error is not small, but it's really small portion out of million observations. It changes the it changes the measure a lot, right? Remember, if you have 10 in this place, then the range would be 70 something. So just because of one observation, your range could change a lot. It's actually a big problem because error can happen like anytime. You cannot rule out the possibility. Therefore, so here's an example. So think about this example, just hypothetical data. It looks like this, and so simulated data, its range is 3.67. So like I simulated data and it happened to be 3.67. But suppose that you happen to have an outlier here. For some reason, this outlier can happen by mistake or can be a real outlier. Because of one guy, range increased this much, right? Right. This is a problem. This is a problem. So range increased to like 4.79. It increased like nearly 30%, more than 30%. So it's not a desirable property. To relieve that problem, we we modify the range, the measure, uh, and we define the interquartile range. Remember, when I introduced percentile, I defined quartile. Quartile is another name of some special percentiles. So quartile is when you divide the probability into four equal parts. Then the first part is divided at 25 percentile, bottom 25%, and the largest part is divided at 75 percentile, which is top 25%. So they are called first quartile, second quartile, third quartile. So you cut probability at these 3 points. to divide the whole probability into 4 equal pieces. And then what we are going to do here is I'm going to assume that assume as if the bottom 25% are outliers, right? So if there are outliers, they will be in the bottom or in the top. So I will drop the bottom 25% observations. Then almost all outliers will be removed. Similarly, I'm going to erase top 25% observations to avoid outliers on the greater side. So if you drop bottom 25% and top 25% observations, then there will be no outliers, right? If so, you cannot say there are outliers more than 50%. I dropped 50% of observations, and if there are like outliers is rare events, so all the outliers will be gone. And then now I'm going to use the middle 50% observations and recalculate the range. So the maximum of the remaining observations and the minimum of the remaining observations and take their difference. That is the new range, but you may interpret this as the difference between the third quartile and first quartile of the original data, right? So it's just a different interpretation. You may just simply take two quartiles and take the difference, or I would explain that as dropping bottom and top and then recalculate the range. They'll be the same. So basic intuition is the same, and then the range is it, like a modified, upgraded to to uh, to be more robust against outliers by dropping the outliers. So it's usually written as IQR, interquartile range, and the greater the variation is, the greater the measure is, right? So it's very robust against outliers. It's like, remember, in the previous chapter, the median is better than the mean when there are outliers. Same thing applies here. Um, like among the 4 measures, range, interquartile range, variance, standard deviation, interquartile range is the most robust measure against outliers. So when you think when you expect extreme outliers in the data, then variance and standard deviation, which are based on the mean, could be too sensitive to them. So in that case, think of like try to use interquartile range instead. That's that's the relationship is pretty similar to the relationship between the mean and the median. Graphically, so this was our previous simulated data, and because of this outlier, this caused some distortion in the range. But now I'm going to drop bottom 25%. So bottom 25% dropped, top 25% dropped, and then the remaining is the middle 50%. Only the light blue are the remaining data, and the minimum of the light blue data is the first quartile of the original, and the maximum is the third quartile of the original data. This is how we define and calculate the interquartile range. So interquartile range is, in the end, it's 1.13. So this is how we define the interquartile range. And so remember, as I said, the most popular pairs of summary measures is the mean and the standard deviation. But as I said, when there are extreme outliers, consider using the median and the interquartile range. So these are the mean and the standard deviation are more sensitive to outliers than this pair. So that's what I wanted to say. Okay, then I'm going to start the definition of variance and standard deviation, which is the most important part of this chapter. We'll continue that in the next one. See you later.